Okay, so problem number 1 on this is kind of like the homework from that first night. I know that I have to use the product rule. How do I know that? There's 2 functions and we're multiplying the 2 functions. So really, I could be writing this as 2x, and then I'm going to go ahead and write the second function as to the 1/2 power. All right, so if I'm going to use product rule, you can go ahead and set it up. Remember how we helped ourselves by just going ahead and doing parenthesis, parenthesis, plus, parenthesis, parenthesis. Some of you don't really feel like you need to do that anymore, and that's fine. But either way, what's going to go first is the derivative of the first term, which is a 2. You didn't have to put that in parentheses. And then just the second term, which I'm writing this time as to the 1/2 power, but you could have written it with just a square root symbol. And I haven't even used chain rule yet. Okay, then I'm just writing the first term. And here's where chain rule comes into play, because in order to take the derivative of the second group, this is like what we did on Monday. We're going to multiply the 1/2 to the front. The inside, though, is going to stay the same. What's going to be the new power on x cubed plus 2? Negative 1/2. And then what do we need to multiply by? Yeah, 3x squared, the derivative of the inside. And so these are pretty lengthy. They're getting longer, but you still don't have to simplify, and this should make it even more glad that you don't have to simplify, because who really wants to simplify that? It's not really that hard, but why do it if you don't have to? Okay, so I kind of use my space over here with 2, so I'm going to use a different color with 2, and I'm going to work it down here. So this time I have a cosine of 6x and a 2x squared. What are your thoughts? Quotient rule, definitely. So go ahead and draw your fraction bar, and if you want, go ahead and put that denominator down there. We know that it's going to be the denominator squared. Some of you were forgetting that on the last test. If that was you, do that part first. That way you won't forget it. So the first thing we need to write is the derivative of the top. Do I need to use chain rule to find that derivative? Yes. Why? Yeah. I need to, because that's 6 right there with the x. That's its own function within the cosine function. So first, I just take the derivative of the shell, which is the cosine. Okay, that's negative sine. The chocolate, 6x, the inside function, that stays the same. And now I got to take the derivative of the chocolate, of the 6x, which is 6. Okay, so all of this is going to go into parentheses. That's the derivative of the numerator. And the rest of this problem is downhill. Okay, because remember, we don't do 2 derivatives at once. We just do write the denominator minus, write the numerator. And the rest of this is just quotient rule. See if I can squeeze in the last piece over there. What goes in the very last blank? 4x. Good. And that's your answer. Again, you don't need to simplify. All right. Moving forward to problem 3. Square root of x. Probably be helpful if I rewrote this as x to the 1/2. What do we need to be concerned with here first? Chain rule or product rule? Which one are we going to set up first? Product rule. We're multiplying 2 functions. Within one of those, I might have to use chain rule, and I will. But this is, again, where you can set it up, and it will help you out. Moving forward, you know what you need to do. And you're not stuck on the problem. So go ahead and try to fill in as many of these blanks as possible. As many as you can. looking up here, you agree with what I've written so far? If I can talk. Huh? Oh, yeah. I did that in another class, and I have no idea why I changed that 2 to a 4. That's something weird in my brain. Fire. I don't know. Maybe just looking at that 4. I don't know. All right, so this last piece is where you needed to use chain rule. So what is the derivative of the second piece? 4 5x plus 2 cubed times 5. Okay? We feeling more comfortable with mixing the two, product rule and chain rule? It's just going to take practice. You're not going to be able to look at this and do a couple of examples and be an expert. You're just going to have to practice it. All right. Number 4 is different. And I really want some more space on 4, so I'm actually going to erase the rest of 3 here. I'll just erase the whole thing, so we're not even looking at it. So on number 4, I have sine of cosecant of x squared. This is not product rule. I'm not multiplying any functions. I'm doing like an f of g of h. It's a chain rule of a chain rule. Okay? This we're going to think of like a peanut M&M. Okay? The outside piece is going to be the shell. And the whole M&M thing is actually going to be way more beneficial on this example. Like yesterday, I think you guys could have gotten, or Monday, you could have gotten chain rule without it M&Ms, but I think this is where it's really helpful. Okay, then what's below the shell? The chocolate. And that's just a regular M&M. So if this had just been X, that's where we could have stopped. But we got a whole nother function, an x squared inside. That's going to be our peanut. And so I don't have peanut M&Ms today. I haven't had time to go to the store. I had to get grades done. I feel bad about it. But anyway, when you're doing this, I want you to imagine eating a peanut M&M. Anyway, we already did this with regular M&Ms, so it shouldn't be that hard to imagine. So you're putting the peanut M&M in your mouth, and what happens? The shell melts. So when the shell melts, that means take the derivative. So what's the derivative of the shell? Cosine. Okay. Is anything happening to the chocolate and peanut yet? Nope. They stay the exact same. And that's what we're going to call round 1. The shell. Okay, a little bit of time goes by. The shell's done. We're done with the shell. Okay. Now we're just looking at the chocolate. Chocolate's melting. So what's the derivative of cosecant? Negative, because it's a we have a negative, cotangent, cosecant, or cosecant, cotangent, either way. Is the peanut changing yet? No. So when I write this, I have to write it as negative cotangent x squared, cosecant x squared. You can't just write x there. You have to write x squared because that's what the peanut is in this case. Okay, so all the chocolate melted off. We resisted crunching down until there's no chocolate left. Okay, so now all you have is the peanut, and unless you want to wait a really long time, you can go ahead and chew up the peanut. All right, and so when we chew up the peanut, what is that? 2x. We take the derivative of the peanut. Okay, so I know this may seem kind of silly, but I'm telling you, especially when we get to these types of problems, you can see how you can get lost in the problem. All right, you're still working like layers, like outside in, but if you have some kind of way to make it make more sense and visualize it, that'll help you. I will tell you, I understood chain rule really well. I've never had a problem understanding chain rule. But when I saw the whole peanut M&M, I thought this was genius. I was like, I understand this even better than I did before, which is good, you know. And I didn't have a problem understanding it before, so it definitely helped you out. Okay, now I want you to scratch out the example on number 5. Okay, I want you to write y equals cosine squared 3x. We're going to do another one of these, but I kind of changed it up. Okay, what's being squared there, by the way? Cosine. So would it be fair to say the whole thing is being squared? I mean, you're always taking cosine of something. I'm not saying the 3x is being squared. I guess what I'm saying is, could we write it like this? And I'm writing it, so I'm going to just tell you the answer is yes to this question. Yes, you can write it like that. So maybe you didn't know this before. Cosine squared, we put the squared here because if we put the squared over here, it's confusing about what you want to be squared. So we put the squared in the middle, but what it really means is take cosine of 3x and then square the whole thing. All right, how many functions are going on here? 3. What would be considered the shell in this problem? The squared, that's the shell. What would be the chocolate? The cosine, and the 3x is the peanut. Now, if that 3x is just an x, then there's no big deal. There's no peanut, whatever, okay? But if it's anything besides x, we're going to have to consider this to be like I'm going to call these peanut M&M problems. So we have y prime equals, remember you attack the shell first. So what's the derivative of the shell? 2. Everything on the inside stays the exact same, not changing. And I'm going to go ahead and put a 1 there, just, you don't need it, but just to be clear that happened, okay? All right, times. Now we're getting to the chocolate. What's the derivative of the chocolate? Negative sign. And again, peanut staying the same for now. That was round 2. And then what do we put in round 3? 3. There you go. Really, these can be as complicated as your imagination. I could have taken this whole thing and put it in a denominator, and then I could have put a square root around that, and then we could just have some kind of like, like those gobstoppers that just change colors every time. We could use that analogy. But don't worry, we're not really going to do that. At least not on a test or anything. Okay, so we're not going to do E. You can cross that one off. We're not going to do it for now. But I want you to look at A, B, C, and D, and I want you to notice the similarities and differences. They all have a cosine, they all have a 3, they all have an x, and they all have a square. But are they the same? No. So we're going to have to really be meticulous about this. And for some of you, you're going to learn something about notation maybe that you didn't know before. So on part A, what's being squared? Only the x, nothing else. What are you taking cosine of? The 3 and the x squared. Okay, there's no parentheses after cosine, but they are implied, so let's go ahead and put them in. All right, you don't have to know just by looking at this whether this is a regular M&M or a peanut M&M. You don't have to know that. You're going to start in the same place no matter what, with the shell, in which case it's going to be cosine. So what's the derivative of the shell? Negative sign. And the inside part's going to stay the exact same. Now, if you can take the derivative of the inside part in one step, you're done. If you need to do another chain rule, well then that was a peanut M&M problem, and we'll handle that. But in this case, I can take the derivative of the inside, and what is that? 6x, and that's your answer. Okay. B. The x is still the only thing being squared, but because they put parentheses where they did, you're only taking cosine of 3. You're not taking cosine of x squared. okay? It's not cosine of 3x squared. You're just taking cosine of 3, you're ending your cosine, and then you're just multiplying it by x squared. So can you tell me something about cosine of 3? Could we figure out what it is? Is it a number? Is it a function? What is it? It's a number. How do you know it's not a function? There's no x. Cosine of 3 is some number, and it's actually, I think, really close to 1, or negative 1, all right, because 3 is really close to pi. So this right here is just a number. So over here, I'm going to write a different problem. If instead of cosine 3, this had just been, say, 5, could you take the derivative of 5x squared? Yeah, what would that be? 10x. You just go 2 times 5, and then you put 1 less on the x. That's what we're going to do here. We're going to do 2 times cosine of 3 times x, and there's only 1 power now. If your brain isn't hurting, it will on the next two. These are so similar, they're just barely different at all. So I want you to ask questions if you don't understand the difference. All right, so on part C, what's being squared?
3x.
Just the 3x. What are you taking cosine of?
3x.
Are we taking cosine of only 3x, or taking cosine of 3x squared? 3x squared. In other words, there's an implied parentheses like that. Okay, and again, you don't have to know how complicated of a problem this is. You start in the same place no matter what, which is taking derivative of cosine. And then we're going to leave everything on the inside the same. Times. Okay, the inside part is 3x in parentheses squared. Can I take derivative of that in just one quick thing? In other words, how many functions is 3x squared? 2. So I'm going to have to do chain rule again. This is a peanut M&M, in other words. So I'm going to have to deal with the squared next. Working your way outside in. You don't just go left to right. You got to go outside in. So that's going to be 2 times the 3x, and the 3x now is just going to have a 1 power. And then finally you can get to that inside part of the peanut, which is 3. And that's your answer. Now, I'm hoping I have somebody in here who's being clever and can tell me an easier way to have done this problem from the get-go. Square the 3x. Let's do that. So if I were to square the 3x, that would have just been cosine of 9x squared. Well, what would the derivative be? This is like A now. Negative sine of 9x squared. That part doesn't change yet. Then take the derivative, 18x. All right, these two are the same answer. Look, 2 times 3x times 3, that's the same as 18x. So, if you're clever, you can get out of doing work. All right, D is the one we just worked on the previous page. Okay, so I'm not going to work D out, but I would like for you to write this right here. That cosine of 3x squared is the same as squared, and then just say C number 5, okay? We already did that one. Right here. Okay, now, the last thing we're going to do today is talk about this table. Have we seen this before? Yeah. Okay, now this is one of those things that they love to put on the AP test. And if you've never seen it before, I need everybody to perk up here. Nudge your neighbor. Give them a hard nudge if you need to. Everybody a heavy carb lunch, I can tell. Because I know I'm not that boring. It's hard to have math right after lunch. It's hard to teach right after lunch, too. Okay, so we've seen this. You're going to be so comfortable with these tables, when you get to the AP test, you're going to be like, oh, this is easy. Where the kid that's taken it at this other school, they're going to know the calculus, but they're not going to know how to answer this question. Okay, I'm just getting you used to it now. So we're going to use the table, but first we need to look at this part right here. This d over dx, what does that mean? Derivative. So f of g of x, this is an M&M problem. This is a chain rule because it's a function of another function. So we start with the shell. The derivative of the shell would be f prime, right? That's the outside function. What happens to the inside function? It stays the same for now. Then we multiply by the derivative of the inside problem, or inside function. And this is actually the formula for chain rule. You remember? You didn't have to remember. I mean, I didn't do it from memory. We did it just from knowing about the M&M. And so what they're asking us here is, okay, well, if x is -1, solve out this problem. So let's replace all the x's with -1. So f prime of g of -1 times g prime of -1. We're going to have to do this in 2 steps here. Okay, first thing is, I need to look up on the table what g of -1 is. So you look in the g column, you look at where x is -1, and that's the number right there. That number is going to replace g of -1. Okay, so I still have my f prime in front, but now in parentheses, instead of my g of -1, we figured out, hey, that's -2. And I'm going to go ahead and just write the second part. We'll do the primes at the same time. Okay, so now we got to look up on the table. Well, what's f prime of -2? So don't look in the f column. Look in the f prime column. -1 right there. Times. And so now we look at g prime of -1. That's right here. -1 times 3. My answer is -3. And that's how you do these. You had one on your test that was a quotient rule problem. This is a chain rule problem. But it's still using the table in the same way. You've got to do the math first, then you look it up in the table and do the numbers. Okay, I want you to do number 9 on your own.
That's just a regular M&M.
Yeah, this is just a regular M&M problem. The table would have to be bigger, and there'd have to be 2 more columns to get a peanut. Those types of problems, I wouldn't expect that. Because the challenge here is already there. You don't need to add an extra element. When you're done, go ahead and just check with someone around you. See if you get the same answer. There's a lot of easy little mistakes that can happen, so be careful. You're stuck on the first step. Here's a hint. This is the very first step. Or you just want to check your first step. Thinking. I'm Chinese again. I don't know how that happens. I really don't. It's the worst thing. Okay, so let's go ahead and go over this. What'd you guys get, those of you that are done? 3 is correct. Okay, and so hopefully you got to this part. This is just knowing the chain rule, doing the number. The next part's not hard, but it is kind of tedious. What did you get for f of 0? Negative 3. And what was g prime of negative 3? Also negative 3. Okay, what about f prime of 0? Negative 1. In this case, negative 3 times negative 1, positive 3. All right, we're not going to do 10. We already did enough today. Okay.